Hello everyone, this is Mesamer Avaran. I've been with Ozone Engineering for almost a year and a half. Before that I was with an electric car company called Byton, and then before that I was 5 years with Ford Motor Company. This is the first turbo machinery YouTube short we have. It mostly focuses on meshing. A little about us, we are the elite channel partner ANSYS. We have been in the Bay Area for 17 plus years and with successful operation and 1,000 plus happy clients. We have expertise in multiphysics finite element analysis and also computational fluid dynamics or CFD, and on top of that electromagnetics, which covers high and low frequency. Here's our territory. We have office in Stanley, which is the headquarters. We also have offices in Portland, Oregon, and staff in Long Beach, California. Here's the list of ANSYS tools we can offer to you guys. On the structures, we have mechanical, ENCODE, LS-DYNA. On flows, we have CFX, Fluent, Forte, and on electronics, we have Maxwell and also HFSS and a bunch of other tools which are for high and low frequency. Some tools also provided in the semiconductor category and some in optics. Materials, we have also Granta. On embedded software, we have different packages of SCADE, and on system, we have TwinBuilder and Medini. So as you see, it's a big list software. Whatever industry you're at, we probably have some tool that can make your product development faster and more efficient. And in other words, we can make your job easier. Just give us a call and we'll be more than happy to help you. Last time I went over the conceptual or initial design of the geometry for the turbo machinery. In this one, we will focus about the meshing. The good thing about the CF Turbo is that it could be totally integrated into ANSYS Workbench. As you see, you can bring it in, do the meshing, and then you can parameterize it, and you can go back and forth and change the geometry also to do optimization. For solving, you can do CFX or Fluent, and you can do also CFD post, which is very powerful in post-processing turbo machinery problems. The way it works is that you can add CF Turbo to Workbench as an extension because we're partner companies. The conceptual design is being exported into TurboGrid for meshing, and after that, the mesh geometry is being fed into CFX or any other solver of preference that you want to use in ANSYS packages. And after that, CFD post could be used because it has a very powerful tool, which is custom built for turbo machinery. So as you see, CF Turbo to TurboGrid and then to CFX. Here's the steps that you need to do in TurboGrid to do the meshing. As you see, you start with geometry, you define the topology, and then you create the mesh and mesh data, and then you analyze it and try to optimize it and maybe improve the mesh a little bit. Here's the schematic of how TurboGrid looks like. It has a tree outline on the left, and it has plots. It can even show you the mesh quality plot. We'll go through one example, and after that, you'll see how it really works. Okay. I think we need to go into the tool. This is, as you see, this is the CFD Workbench. So we have a problem. We have the problem already set up here, but I want to do it from scratch so you can see. As you see, you can add CF Turbo to the Workbench as an extension. I'll just bring it in. Then I click Edit. For example, one of the problems we solved was the axial fan. I'll just use that problem just for simplicity. This is the problem we had. This is the geometry that was generated. Then after that, you go to project, you go to ANSYS Workbench. You have a bunch of parameters here because it's a template-based tool. You have all these values that you have put manually, but you can modify it or make it parametric and then do optimization. So let's say I want to see the effect of tip clearance. I want to have it as a parameter, and also shroud diameter outlet dimensions. Okay, that's good. So it's all parameterized inside Workbench. And then I want to export two geometries. Let's say the impeller or the rotor. This is rotor. And I want to send it to TurboGrid. And I say add, and also I want to do the stator. Ansys Turbo Grid, and then add. So you have both of these inside. Now you just close it, save, file, and just close it here. I don't need CF Turbo anymore. As you see here, the values are parameterized, so you have a parameter set here. And in the setup, I'll just update it. It's all there. You have it already. Just it's refreshing. So you see, you have the geometry there, you have the impeller, and you have the stator. Let me just update these two. Update. Okay, so you have two meshes getting out, one for a rotor or impeller, one for a stator. Now you got to send these to a transfer data to a turbo grid. We want to do that for meshing. One is for impeller, transfer data to turbo grid. This is one for the stator. And after that, you need to send this into a CFX solver. This is one half of the geometry. The other half, which is the stator, you can just drag and drop from here all the way to the setup, and you should be all set. We don't have too much time, so I'll just go through one of the meshing settings, and then the rest is up to you. We can do it later. So you go to Edit. TurboGrid is customly built for turbo machinery. You see, this is one of the passages which has been shown here. This is just a rotor or impeller. But if you want to see the whole thing, there's like two of them. And if you want to get the whole thing, that's the whole fan. But because it's being periodic, we just need to see one of them. Okay, check, make sure your topology is fine. So this is geometry. This is the inlet, which is shown in white color. And this is the outlet, which is shown here, which is great, looks right. Then you have the topology set, which looks right. There's no problem in that. And then after that, I think all you need is to go create the mesh for it. So right click on it. You deactivate the suspend objects and it would start meshing. You gotta be a little patient with it. It's running as you see. You also have these toolbars here so you can define the, let's say, tip clearance. You even can parameterize some of these in a lot of, it's just a warning, it's not a problem. We'll get rid of it later. You see it creates the mesh for you. It's in different layers, and as I mentioned, you already have the CAD, but you also can play around with parameters like tip clearance and modify it or no. It's all up to you. I can hide or have the geometry. This is the mesh. You can create it this way too. As you see here, there's a mesh button. You can create it. And you see there's a couple of warnings and also some errors. Actually, you can run it, but it's good. You don't have to resolve all this. It's just a warning, but it's good to resolve it. Here, just the value, the angles is a little out of the range, but it's not that much. We can change these. The values that we have by default is quite rough. We can make it a little easier for the tool. Let's say if I make it maybe 175 and for instead of 15, I make it 10, apply. I think this one is around, okay, let's say, okay, that was just a warning. We just got rid of it. And the other thing is that you look at the 3D mesh. Fortunately, the 3D mesh that we have here is quite good. As you see here, you can even have the blade, leading edge, trailing edge, hub, and mesh on all these structures too. Different parts of the geometry, like outlet, you have mesh in all these locations too. So I would say this is how it looks like. And then the important thing is the 3D mesh that we are looking at. It's just one of the faces, but it has a bunch of these faces that goes from the surface, which is the hub, all the way to the tip. And we can even play with that. If you go here, let's say case 15, if you make it, let's say 25, it goes further high. If you go maybe 20, somewhere in between. If you go maybe 5, it goes closer to the hub. Maybe 10, a little higher, as you see. And you have a quite good quality mesh. And in the back, I've been trailing edge. It's fine enough to capture all the vortexes behind that. So I'll just go with the default, which was 15, which is in the center, roughly, and I'll stick to it. Sometimes you can play with parameters to just make it, for example, a little higher quality, mostly for the I would say, quality of the cell. When you go to the volume mesh, you can play around with these variables and maybe instead of 3.4 to kind of improve the mesh quality. And now we want to even see the mesh quality to see how it looks like. If you click on it, you see the color. It's just that orange color or turmeric color. But let me just hide the geometry here. And if you want to, you can say it as a variable. And there's a lot of, make it local. A lot of parameters you can choose that shows you the mesh quality. As you see, the mesh quality is like higher in these locations and lower in these locations. You can even put a legend for it to define it, and then to show you exactly what the value is. Okay, I think we're good. So as you see, it's a very straightforward process, and it's specifically designed for turbo machinery, so you don't need to do much. Just you need to bring the CAD and pretty much push the, I would say, mesh button, so it does it for you. Let's see, that's the total mesh, and that's with the geometry around it. Thank you for your time and attention. And feel free to let us know if you had any questions. We will have very happy to answer to you. Have a great rest of the day. Bye.